Probability distributions of discrete random variables. Introduction. New York City is the largest city in the United States and one of the largest cities in the world. The US Census Bureau estimates that between 2000 and 2010, the population of New York increased by 2%. The population in 2010 was 8.175 million. Imagine that you are a city planner. You want to make sure that the city residents have enough housing. You specifically need to ensure that there are enough rental properties to meet the housing demand. In order to do that, you will need an accurate estimate of the size of a typical rental household. In other words, you need to find the mean number of people per household living in a rental properties in New York. The following table shows data from the 2011 New York City Housing and Vacancy Survey. The survey reports the number of New York City rental properties by household size. There are so few households with more than 8 people that we may ignore them. Well, complete the table. Number of people in a rental property, it's denoted by X, which is a discrete random variable. So number of people in a rental property can be just one person, two people are living in a rental property, 3 or 4 people, or 5 people, or 6, 7, and 8. If X is equal to 1, just one person living in a rental property, the frequency of properties, which is denoted by F, or the count, is 720 to 40. How do we find the relative frequency? What's the meaning of the relative frequency in this case? It means that what is the probability that X is 1? The frequency of X equals to 1 over the total sum. It means that N is equal to the sum of all numbers in the second column. X is equal to 2. The frequency is 599,488. How do we find the relative frequency? Or in another word, how do we find the probability that X is equal to 2? To do that, we have to divide the frequency of X equal to 2 by the sum of all of these frequencies. To find the rest of the relative frequencies, we have to follow the same step. So in this example, our X is given. The frequency of X is given. We're finding the relative frequency, which is F, divided by N. X is equal to 1. Its frequency is 720, 240, Well, the relative frequency is 720, 240 divided by n. What is n? N is equal to 2,098,267. When we do the division, we approximately get 34.3%. So the probability that x is equal to 1 is 34.3%. You only have one person living in the rental property. What if x is equal to 2? The frequency of x equal to 2 is given to us, 599, 488. How do we find the relative frequency? You have to do the division, a little bit of algebra. So 599, 488 divided by n, which is the sum of all frequencies, 2, 098, 267. If we do the division, it's equal to 28.6%. So what's the meaning of that? It means that the probability that x is equal to 2 persons in rental property is 28.6%. We can continue the process. We have more number of residents living in rental properties, 5, 6, 7, and 8. 3 has a frequency 358, 176, and the relative frequency is 0.171 or 17.1%. X is equal to 4. We have 233, 596. After we do the division, we get approximately 11.1%. X is equal to 5. The frequency is 108, 317. And if we follow the division, we get approximately 5.2%. Well, when x is equal to 6, we get 47, 330. These numbers are given to us. We just need to find the relative frequency, which is 1.1%. And when x is 2.3%, okay, this is 2.3%, 1.1% is for 7. So for 7, you have 22, 0.32, 1.1%. And finally, if x is equal to 8, you have 9,088. And the relative frequency or the probability is 0.4%. So we found the probabilities for each of these cases. If x is equal to 1, this is the probability, x equal to 2, the probability 3, 4, 5, 6, 7, and 8. The number of people who live in a randomly selected rental property is an example of a discrete random variable. We can list the values of a discrete random variable in order. In the example above, the random variable x can take the values 1, 2, 3, 4, 5, 6, 7, and 8. If we randomly select a household from this population, the probability that a household has a certain size is equal to the relative frequency of that household size. A discrete probability distribution is a list of all the possible values of the discrete random variable together with each value's probability. Each probability is between 0 and 1, and the sum of all probabilities is equal to 1. We can visualize the discrete probability distribution using a relative frequency histogram. The household is equal to 1. The probability that we have is 34.3%. The household size is 2, and the probability that we calculated was 28.6. The household size is equal to 3, and the probability is 17.1%. The household size is equal to 4. The probability is 11.1%. The household size is equal to 5, and its probability is 5.2%. The household size is equal to 6. Its probability is equal to 2.3%. The household size is equal to 7, and the probability is 1.1%. And household size is equal to 8, and the probability is equal to 0.4%. As you can see, the graph skewed to the right. The tail is on the right-hand side, and the graph skewed to the right. So question 2 says, what's the shape of this probability histogram? It's skewed, as we can see, to the right. It means that as the size of the household increases, the frequency decreases. We get smaller frequency. Question 3 says, imagine that we select a random New York City rental property. The following problems will ask about the probability of selecting certain types of properties. Use the probability distribution in question 1 to answer these questions and express your answers in appropriate probability notation. For example, the probability of selecting a property with less than 2 people living in the would be written as the probability that x is less than 2. Note that it doesn't include 2. It doesn't have any equality. It is just less than, which would equal approximately to probability that x is 1. So 34.3%. Find the probability that the rental property we select has at most 4 people living in it. B, find the probability that the rental property we select has more than 5 people. And C, find the probability that the rental property we select has between 2 and 4 people living in it, inclusive. It means that we are including 2 and 4. Well, part A, we can use the information that we have. Part A says, find the probability that X has at most 4 people. When we are saying at most, it means that we are working with less than or equal to. So at most 4. At most 4, it means that it can be 1 or 2 or 3 or 4. We have each of the probabilities, we add them all together. It's approximately 34.3% plus 28.6% plus 17.1% plus 11.1%. This is approximately equal to 91.1%. Part B of the question says, find the probability that you have more than 5 people. B, the probability that X is more than 5. More than, absolutely greater than. More than 5. It means that it can be 6, or it can be 7, or it can be 8. So we need to add 3 probabilities. X is 6, probability that X is 7, plus the probability that X is equal to 8. 6 is 2.3%, 7, 1.1%, and 8.4%. By adding these together, we get 34, 3.8%. And C, to find the probability that we have in between 2 to 4 people living in the, these rental properties, we have to add 2, 3, and 4 probabilities, which is 28.6% plus 17.1% plus 11.1%. So the answer to question C is 56.8%.